Up until now you've used degrees to measure angles. 30 degrees, 60 degrees, 360 degrees in a full circle. Now we're going to introduce another unit, the radian. This is a more fundamental unit than the degree. The degree is rather arbitrary. There are 360 degrees in a circle, but why? Why not? Why weren't there 100 or any other number? There's nothing very fundamental about the degree. It's just a useful unit. The radian, though, comes from a very interesting and fundamental property of circles, and it's linked to one you already know. Let's have a look at this. So if we have a circle of radius 1, then the ratio of the circumference of the circle to the radius is 2 pi. What if we take part of the circle? Well, do the easy part, take half a circle, a semicircle. The arc length of a semicircle divided by the radius will be 1 pi. That's reasonable. Now let's take a point and just move it around different parts of the circle, different lengths of arc, and see what we can find. So let me draw in the arc, and this number in GeoGebra gives me the length of the arc, how long B1 is. Now we know the radius of this circle is 1. Why don't we just, to see what happens, try making an arc length of 1. So I'll move this point B1 until the length up there is 1. Whee. Getting there? Too far. There we go. And interestingly too, this gives us the angle, 57.39, and it shows up here. Okay, well, that was fun. Let's do it now for another circle. Let's have one of radius 2. And again, take a point, show the arc, and look at this length. And this time we will go round until the arc length is 2. So you see what I'm trying to do? Get an arc length the same length as the radius and see if we can find something interesting from that. Round we go. Where are we? 1.4, 1.8. There we go. And look at this. Let me show you something very interesting. When the arc length equals the radius, we have the same angle. And that angle we call 1 radian. So that's why the radian is such an important unit of measuring angles. It comes from one of the really important properties of circles. And in fact, within sort of just the jumping error, these here, we see that it's about 57.4 degrees. You don't have to memorize that. What is important though is that you get a basic feel for the sort of magnitude of a radian. It is getting up towards 60 degrees. Okay, what can we do with that? So just remember this really important point then. For any circle, when the arc length equals the radius, that's if we straightened that arc length out, made it a straight line, measured its length, it would be the same as the radius. Then we have an angle of 1 radian. So this is summarizing, well, when the arc length equals the radius, we have an angle of 1 radian. So the formula for finding the angle in radians, not in degrees. Now, to find the angle in radians, you simply take the arc length L, divide it by the radius r, and you have the angle in radians. Or often the formula is rearranged and put in formula booklets and textbooks and so on. L equals r theta. The arc length equals the radius times the angle in radians, not in degrees, must be in radians. Then we can go a step further. Let's take not just a small part of the circle, let's take the whole thing. So the arc length now is the whole circle, the circumference. How long is that? We've known this for years. We know the circumference of a circle, 2 pi r. So the angle for a full circle expressed in radians will be the arc length of circumference, 2 pi r, divided by r, just 2 pi. This is really important. There are 2 pi radians in one circle. In other words, 2 pi radians equals 360 degrees. That's the conversion. And so with that, we can work backwards and find how many radians are equivalent to 180 degrees, 90 degrees, and so on. And this table of the main basic angles that we're interested in terms of degrees, 0, 30, 45, 60, 90, 180, 360, you need to know their equivalent in radians. You need to know that 30 degrees is pi by 6. You need to get that in your head, not just be able to look it up in tables or work it out. And 45 degrees, pi by 4. 90 degrees, pi by 2. You need to know these. It's really important. It will help your calculus enormously and your trig. And then once you've got used to using radians to measure degrees, to measure angles instead of using degrees, then in the next video I'll move on to looking at how to work out very simply the basic trig ratios, sine, cosine and tangent of these main angles in this table.